So Ravi, if you could progress to the next slide, I'll get us kicked off. And on behalf of ACEINNA and our global partner, WPGA Americas, we hope you and your family and friends are safe and well during this unprecedented time. We're very thankful that you were able to join us today for this webinar, and we would like to welcome you to the first of our technical webinars in a new series that will help you use our software, algorithm, and hardware tools to develop autonomous systems quickly, easily, and inexpensively. ACEINNA is a unique company in the fact that we not only design and test and manufacture highly precise sensing systems based on the fundamental physics of how gyroscopes and accelerometers work, but we're also a fully integrated software platform provider and vendor. So with our partner WPGA Americas, our friends there, thanks to Mike Pecoraro and the team under Rob and Chris, we've come together as two companies to provide this IMU development environment and this webinar series. So with that, I'd like to introduce our two speakers today, Ravi and Stephen. Ravi is one of our application engineers on the West Coast, and Stephen is one of our application engineers for inertial based on the East Coast in Boston, where I am also residing, and our headquarters for ACEINNA is located as well. So with that, Ravi, I'll hand it over to you and we can get started.
Thanks, Michael. So in this webinar, we're going to cover different topics. So getting started with familiarizing with OpenIMU 300 CI evaluation kit, giving you an overview of software development environment that ACEINNA has to offer, and connecting to the hardware, and I will show you a live demo of it. The rest of the topics, the loading the IMU application, how to modify the source code, and displaying and logging the data will be covered by my colleague, Stephen. And finally, we will take the questions towards the end. So in our OpenIMU family, we have different products. I would like to give you an overview of the products that are available. OpenIMU 300 CI, which is a 9-degree freedom, which means it has a 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. It's an embedded IMU application, and it has Pi and UART as an interface. We have OpenIMU 300 RI, which is also 9-degree freedom, and it comes in a ruggedized casing with IP69 rating. And it has CAN and RS-232 as the interface. We have OpenIMU 330 BI, which is a triple redundant, and it is a 6-degree freedom, which means it has 3-axis accelerometer and 3-axis gyroscope, and it is a triple redundant. And it comes in a surface mount with a ball grid array packaging. And it has Pi and UART as an interface. So when you order an evaluation kit of OpenIMU 3i, this is how the packaging looks like, and I will talk you through the main component that it comes with, which is OpenIMU 300 CI IMU module, and it has the evaluation board, and it has a text fixture adapter, which is used to precisely mount the IMU in a precise location to the evaluation board. And it has ST-Link JTAG port, which is used to program the microcontroller. I will talk in detail about each component individually in the coming slides. So let's look at the main component, which is OpenIMU 300 CI. As it is an open source, which is a 9-degree freedom, which is a 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. And it has Pi and UART as an interface. As it is an open source, we have ready-to-use algorithms that are available on our website. You can download it and you can change it according to your needs, and you can upload it to the unit. The algorithms that are available is IMU application algorithm, which gives a raw data of accelerations and angular weights. We have vertical gyro, attitude, and heading reference system application, which gives a complete attitude information which is roll, pitch, and yaw. And we have inertial navigation system application, where you can connect external sensors like GNSS receiver or steering angle or odometer in order to get the complete ACEINNA solution with the position, velocity, attitude, and other parameters as well. So this comes in ionized aluminum housing with a PCB mount, and it is a miniature packaging as well. So let's take a look at what the evaluation board looks like. So the main components of this eval board is it comes with a virtual COM port USB interface that you can connect directly to your PC. And this cable also provides the power to the eval board over here. And we have the power switch to turn on and off the power. And we have the eval board along with the coordinate reference frame mount diagram on the board as well, which helps you to mount it properly on your vehicle or any platform. And also we have the OpenIMU ZI unit that are mounted underneath this board, which is not visible in the picture, but it's mounted underneath the board of the PCB. And we have the JTAG connector along with the ST-Link, which is used to connect to your PC in order to program or directly upload the ready-to-use algorithms onto the unit. And this is a test adapter, which is used to mount the OpenIMU correctly and precisely to the eval board in a correct location. And finally, we have the 12-pin pins available over here, which is used to expose the IMU module to the other external reference units. Like if you want to use the synchronization, and you can connect the GNSS receiver and give 1 PPS signal to the IMU module. So all this information and the pin description and the eval kit information is readily available on the documentation link. So software development environment. So let's look at the overview of all the software development environment that ACEINNA has to provide. So with ACEINNA hardware, we do provide different tools and IDEs and extensions. And so IDE and the tools that you can use in order to program or change the algorithms according to your needs and requirements and upload them to the unit as well. And we do have the ACEINNA extension. And we have the web GUI tool, which is used to run the simulations or look at the data in the real time and record and collect the data and do the analysis. And finally, we do have the community where you have the forums so you can ask any questions. And we have a great support team that is readily available to solve any kind of issues or problems that you have with the product. I will talk in detail about each and everything in the coming slides. Let's look at the free software IDE that is available, which is the Visual Studio Code, and you can install the ACEINNA extensions as well. With the ST-Link hardware, you need to install the drivers along with the utility tool, which is used to program the microcontroller with the ready-to-use algorithms that are available. And we have the ACEINNA Navigation Studio, which is a web GUI tool, which is used to collect the data and see the data in the real time and run any simulations. This also has the app marketplace where you can download different applications for your unit and upgrade it onto your unit as well. We have source code available on the GitHub for different applications and algorithms. All the source code is available, but you can change it according to your needs and requirements and upload to the unit. And we do have like a data capture servers in Python where you can download it and change it as well. So all the information about the OpenIMU, different products that are available, detailed descriptions about the pin configurations or how to get started with all the tools, and everything is available online in the web link. And we do have the support forum where you can have the general discussion about the latest technologies or any kind of sensors and navigations technologies. And if you have any particular questions in regards to a particular product of the family, you can have a discussion in the product link. So getting started with the PC tools. So we do have, you can get started in the platforms like Windows 10 or 7, the Ubuntu, and the Mac OS. Make sure you have the ST tools that are installed in your PC, the drivers as well as the ST-Link programming utility. This tool is utilized to program the microcontroller with the ready-to-use algorithms, which will show you a live demo in the coming slides. Make sure you have the latest Python installed, which is 3.8.2. And we do recommend the Chrome browser as it's much more compatible with the tools that we have. So getting started, so you need to download and install the Visual Studio Code depending on the platform that you have, whether it's Windows or Ubuntu or Mac OS. And while installation, make sure you check the box, add to the path during the installation. And you can click on the extension in the Visual Studio Code and search for ACEINNA and install the ACEINNA extension. And also make sure you have the Python extension installed in the Visual Studio Code. Let me quickly give you a live demo how it looks like. So this is the Visual Studio Code, and if you click on the extensions over here, and then you can search for ACEINNA, and click on the install button, and it will install the ACEINNA extension. And similarly, you can search for Python and click on the Python and make sure it's installed as well. So once it's installed, so this is how the ACEINNA web page looks like. Make sure you have the show as a startup checkbox text. So this is useful. On the left-hand side, we have all the libraries on the platform. So whenever ACEINNA releases new updates to the libraries, there's a red checkbox that pops up saying that there's a new available libraries available to install. Then you can click on the library and click on the updates. So depending upon the product that you have or application, you can get the latest firmware or the source code from here. You can click on the update and it gets updated. Similarly, with the platforms, whenever there's an update, you can get the latest update in terms of all the development platform for which consists of the customized algorithms in the navigation code. So ACEINNA Navigation Studio, this is a web-based tool which is used to program and co-deploy the firmware or the binary file directly onto your OpenIMU hardware unit. And this web-based tool is also useful for looking at the data in the real time from the sensor. If you want to capture the data or record the data, you can do it, as well as you can analyze the data results. And we show all the results in the terms of graphs and all the information. And we do have the simulation over here where you can create the virtual IMU based on your requirements and select the motion trajectory that you wanted to have, and then run the simulation in order to look at the results. So this is a web link. And we do have the ACEINNA forums as well, where you can have a general discussion in terms of the navigation field, the IMU sensors, GNSS receiver, and so on. If you have any particular questions in the particular product of the family, you can click into this particular link, and you can have any kind of questions or issues that you're facing. And we have a great support team who are readily available to solve and fix the issue within no time. Let me give you a quick overview, quick live demo of the ACEINNA Navigation Studio. So this is the ACEINNA Navigation Studio. So in order to get started, first you have to create an account. So click the account and register yourself with the email, and then you can get started. In getting started, it gives all the detailed information about the tools that I've just talked about. And for simulation, it also has the entire description of the use the ACEINNA Navigation Studio with the different steps and quick start. And you can click on the simulation over here and click on the sensor models. Over here, we have like a different parameters that are available to the customers. So you can select the axis type, whether you want 6-degree freedom with 3-axis gyroscope and 3-axis accelerometer, or else if you want to 9-degree freedom along with the 3-axis magnetometer, you can select this checkbox. And you can select the accuracy levels, whether you want the high accuracy or mid accuracy or the low accuracy. And coming to the gyro specifications, you can change the parameters as well, specs in terms of bias instability, angle random walk. For accelerometers, you can change the parameters like bias instability, and the velocity random walk. And if you have the GNSS receiver, you can switch it on. You can give the position and velocity information and save this module and give it as a name. And then you can select the motion generator. If you have your own particular file, you can upload it, or else like we do provide a free motion generator file that you can click on it, and it updates all the values over here, and you can save it with a name. And then you can click on the run and select the files that you just saved. And you can select the algorithm settings that you wanted to run and click run. And you can have all the results over here in terms of the graphs, or you can save the file as well. We will do a separate webinar in order to run and show how the simulation works in detail in the coming weeks. So if you have the OpenIMU connected, you can come to the devices and click on the OpenIMU, and you can see all the information of the devices over here, and you can see the real-time data which is coming up, which will show in a live demo in a few slides from now. And the other important thing is we have the app marketplace. So based on the product that you have, OpenIMU 300RI or 300CI or 330BI, we have different applications that are available that you can upload onto your unit and work on it, which we will also show you a live demo how to do that. And finally, as I talk to you, like this is a forum. Once you click on it, we have general discussions that you can have any kind of discussions in terms of navigation, or if you have any particular questions in terms of any particular product, OpenIMU family, OpenRTK, or INS 1000. So click on it, and we have like discussions on different topics or any kind of issues. We have a great support team who are very quick to answer any kind of questions that you have in order to solve the issue and get it working. So connecting to your OpenIMU unit. So there are 3 ways of running the OpenIMU server to connect to your OpenIMU unit. So running the OpenIMU server from executable, running the OpenIMU server from the Visual Studio Code terminal, and finally running the OpenIMU server directly from the Python source code. So I'm going to talk about all the 3 ways of doing it, but I'm going to show you a live demo of the first one and the third one. So the first one, running the OpenIMU server from executable. So based on your platform that you have, whether it's Windows and Mac OS or Ubuntu, so download the executable directly. It's a zip file. You have to unzip it. And then make sure you have the evaluation board connected to your PC through the USB cable. And then run the executable, which will scan all the available ports and connect. As you can see, it gets connected and it shows all the information about the OpenIMU unit. And finally, you can use the Navigation Studio, which is a web GUI tool that I've showed you, in order to view the data in the real time. So let me show you a quick demo of this one. So after you unzip it, go to the folder and click on the executable. So it auto detects and connects directly to the COM port to which the unit is connected. As you can see, this is OpenIMU 300 unit, and this is the part number of the unit, and this is the available firmware that is there on the unit, and this is the serial number. And you can use the ACEINNA Navigation Studio to look at the data in the real time. So and the second way is running the OpenIMU server from the Visual Studio Code terminal. So open the Visual Studio Code and open the terminal and install the server application if it is not installed previously. So the command is pip install OpenIMU, and make sure you have the evaluation board connected to your PC through the USB cable, and then run the application, the command OpenIMU, and it connects directly to the unit. And then you have to start the server. The command is server_start. And finally, you can use the Navigation Studio to view the data in the real time. And you can type the stop or exit to stop the server. And the third and the final way of connecting to your unit through the Python source code. So you have to clone the Python OpenIMU GitHub repository. So for that, you have to create a new folder and then clone the repository with the command git clone and the GitHub repository web link. So open the folder in the Visual Studio Code, and you can save the workspace as desired. So for installing different packages, you have to create a virtual environment, and you have to add this environmental variables to your path. So depending upon the Python that is installed on your platform on the PC, if it is the Python 2.7, make sure you have to run this command pip installed -r requirements -2.x.text. And if you have Python 3 version, and you can run the pip installed -r requirements.txt file. So all this information is available in this particular file, readme.md, in the Git repo of Python. So open the folder in the Visual Studio Code and go to this particular file, which is a webserver.py, which is a Python script, and then run the script. So once it runs, it gets connected to the OpenIMU unit that is available. And finally, you can use the Navigation Studio to view the data in real time. Let me show you a quick demo of how it is done. So open your Visual Studio Code and open your Python OpenIMU GitHub repository folder over here and go to the webserver.py and click on the green Run button, which runs the Python file in the terminal. Once it runs, it gets connected to the unit that is available with the COM port, which is COM12, and the baud rate. And it shows what is the unit and the EVK. And this is the part number of the unit. And this is the firmware and the serial number. And finally, you can use the Navigation Studio web tool in order to look at the data in real time. So later topics will be covered by my colleague, Stephen. Over to you, Stephen.
Thank you, Ravi. Okay, so this section will describe the different ways of programming one of our IMUs. This first picture shows the connections required to upload one of our pre-built IMU applications using Navigation Studio. It's quite a simple connection. It's simply a USB from the PC to the J1 micro USB connector on the evaluation kit. The method of doing that is, with the board is connected in the previous picture, you run the OpenIMU server via one of the methods Ravi already demonstrated. Then you open the Navigation Studio and select your desired application and click on the Upgrade button. I'll just show you what that looks like. So with the server already running, I open Navigation Studio, go on to Code, select Apps. You see I've got Match Connected Device selected, so it's limiting me to the devices that I actually have connected to the PC. I can select one of these, such as the IMU application, and just click the Upgrade button. There's also the option to download the binary for this application, and you could use the ST tools to write this binary directly to the OpenIMU. I'll show Navigation Studio in more detail in the displaying and logging data section, how to use these applications. Next, I'll show you how to program the IMU from the source code. The connections are the same as previously, but we've added the ST-Link programmer and debugger to the JTAG interface of the evaluation board. Before doing any code development, it is important to save a backup image of the IMU. This is done with the ST-Link programming utility, and there are three main things that are backed up. First, the application, bootloader, and also the calibration data. Depending on the OpenIMU device you're using, there will be a different image size. So as you can see for the OpenIMU 300, which I have connected at the moment, there's a different image size to the OpenIMU 330. And I'll just demonstrate this now. So the first step is to click this Device Connect button. And then it's simply a case of making sure that the start address and the size are correct. And then File, Save File As, and you can save that up as a backup image. If you do need to recover the device, You can click Target, Program and Verify, and that will allow you to write that saved image back to the part. So regarding updating the IMU with user-generated code, we have example code for the pre-built applications, and these are available on GitHub, but you can also access them through the VS Code integrated development environment. In this section, we're going to build an IMU application from the source code and upload it to the IMU using VS Code. The steps are to open the ACEINNA extension in Visual Studio Code, select the desired example, and then connect the ST programmer and debugger as shown in the last connection image. And at that stage then, you'll notice that at the bottom of the page, there's a tick box and an arrow. Clicking the tick will build the application, and clicking the arrow will upload it to the OpenIMU. And at that stage, the OpenIMU will be programmed. So just to show that in practice, so having opened the OpenIMU extension, I click on the IMU examples, and it's an OpenIMU 300ZI that's connected at the moment. So I'll drop down and I'll use the AHRS application. So this will give us pitch, roll, and yaw. And clicking import then will open that project in the extension, in the integrated development environment. Now, that will look like this. And as mentioned earlier, to build the project, you click the tick. This should just take a few seconds. And then we can upload it to the OpenIMU. And when this process completes, the OpenIMU 300ZI will have been programmed with the AHRS application. Next, I'm going to give a brief overview of the source code and the sections that a user might edit for a customized application. So the main sections of the source code that are of interest to us are the OpenIMU core and the user source code section. The OpenIMU hardware runs an open source stack, and that's written on top of the standard ARM Cortex libraries. In that stack, we have various functions, including the extended Kalman filter code. And that algorithm is available to be used as is, or you can customize that for your own specific application. And as mentioned previously, all the source code is available on GitHub. So for a little bit more detail on the core, this consists of the board support package and the free RTOS. So we've got default pre-filtering and calibration functions. There are data acquisition, message functions, and serial debugging functions. And finally, it also includes the bootloader, the Python-based message decoder, and the data capture functions. However, under source/user is where the vast majority of the edits made by users will be made to these files here. I'll go through those in a little bit more detail later, but these allow you to edit the algorithms, the interface you want to use, whether you want to use a SPI or UART on the 300ZI, or a CAN or RS-232 on the 300RI, etc. Also of note at the bottom here is the OpenIMU.json file. So this describes the input and output messages and the configuration parameters of the OpenIMU. So with this file, without any additional coding, you can customize the graphic user interface of Navigation Studio. So just to expand upon that section a little bit, inside the library, core, this is where the vast majority of the core code resides, such as algorithms for the extended Kalman filter code. As I mentioned earlier, the vast majority of the edits made by a user will be in this section, source/user. So here, for example, if I were to open up userconfiguration.c, you can see where you can set the default configuration for the device, what baud rate you want to use, what type of packet you'd like to use, what sort of filtering you want to have on the accelerometer and the gyro, and indeed the orientation, or how this IMU is mounted in your application. In userconfiguration.h, we're just showing the functions that are available to the user, such as update the user parameters, get all the parameters, etc., and to save the user configuration. In the user algorithm.c file, you have the option to initialize your own algorithm and to also call it. And finally then, in the user messaging files, so we have separate ones for the SPI and the UART interfaces. And these define the input and output SPI messages that are available, sent over to the server application. I mentioned the OpenIMU.json file earlier. And this is the file that allows you to configure the GUI of the Navigation Studio. So you can see under this first section, we've got various different options you can choose. So you can select the baud rate, the packet type, what the packet rate is, the filtering, etc. And you notice when I do the live demo later with the Navigation Studio that these are the configuration options that are available to the user. Also defined here are the packets that can be sent back and forth. So you can see here for the Z1 packet, we're sending X, Y, and Z accelerometer data, X, Y, and Z gyro data, also magnetometer data. And in terms of plots, we've got plotting X, Y, and Z acceleration versus time, and also angular rate versus time. One final section to point out is when we clicked the build button earlier and built this application, the binary itself can be found at the following location under .pio/build, and it's this file here, firmware.bin. You could save this and use the ST-tools to write this to the part directly. And this is basically the same binary that is available in Navigation Studio in the code section. One thing to note, if you are using the ST-tools to write a binary application directly to the part, you should check the start address that you use. So you don't want to overwrite the bootloader and configuration data. So this information is in our documentation. That's the OpenIMU.readthedocs.io. Next, we'll show how to display and record the IMU data that is being collected by the Python server. For this, you just need to have the evaluation kit connected to the PC via the USB. So with this PC connected, you need to run the OpenIMU server via one of the methods Ravi demonstrated. Then open Navigation Studio, and under OpenIMU, select that under the Devices tab. Now, up in the top right-hand corner of the page is the Settings button. Clicking this opens the unit configuration window. And the parameters that you can select here directly reference the parameters in the OpenIMU.json file. So if you were to change those, different options would show up under the configuration here. With this, you can change all those settings, such as packet type, rate, the filtering that you use on the accelerometer and gyro, etc. Under the Settings button is the Play button. Hitting that allows you to display the live sensor data. Now, next to that button then is the Record button. This can be used to save the live IMU data to a .csv, which can then be processed by the user. This saved data can be viewed by clicking on My Files, and you can either view the plots or download the .csv. So I'll just show that now. So with the server connected, I'm going to open Navigation Studio, click to OpenIMU, and you can see that that has connected. Now, I mentioned over here under Settings, we have Unit Configuration. Here you can select the various different packets you want to show. So I showed you the Z1 packet earlier in the code. You can also select the baud rate, how often you want those packets to come, the filtering you want to have on the accelerometer and gyro, and also the orientation. Save this, and then you can select the various parameters that were available in the graphs in the OpenIMU.json. So that was acceleration and angular rate. Clicking play then displays that live data, and you can see as I rotate the OpenIMU evaluation platform, you can see the data being displayed on the screen. You also have the option to zoom in on this data, so you can see this accelerometer data. If I were to change that to max to 20 meters per second and the minimum to -20. You can see we've zoomed in on that data. You'll notice that the z-axis, of course, is at in around -9.8 meters per second, and that's due to the acceleration due to gravity. So, another one of the packets more relevant to the AHRS application is the A2 packet. And then you have a wide variety of things you can display here. I'll just select them all, click play. And you see we've got accelerometer, angular rate, and attitude with the roll and pitch. We also have the heading and attitude indicators available. This data, as I mentioned, can be saved. So you can just input a name for a .csv file, save it, and then you can go to My Files, and that data is available for you to download. And you can process that data externally. So, in summary, to the user, we provide a platform that is highly configurable and a choice between pre-built applications and also some source code implementations. You can choose one of the three methods to run the data capture server, either the standalone executable, running that server from VS Code, or running the server from the source code. Then you can program the IMU, either with Navigation Studio, writing the binary directly using the ST tools, or compiling, building, and writing using VS Code. This data then can be displayed or recorded with Navigation Studio. So our main aim is to enable quick development and a short time to market for our customers. We provide a fully featured IDE that's free to use, and that's VS Code with the ACEINNA extension. We have free source code and example projects on GitHub. We also have the hardware evaluation platform and comprehensive documentation at OpenIMU.readthedocs.io and the support forum that Ravi showed earlier. So thank you for joining us today, and this is the first in a series of webinars we will be running. In the coming weeks, we'll have webinars on topics such as code development, where you can edit source code to create a custom CAN message for the OpenIMU 300RI, and also on our simulation environment, where you can evaluate the expected performance of an inertial navigation system. After this webinar, you will receive a feedback email, and any comments that you might have on how we could improve our sessions or tailor them to better suit your needs would be appreciated. So at this stage, I'd like to open the floor, and if there are any questions about what we have presented today, please feel free to ask them.
So I see there's a question from David Kelly. Maybe I'll read them off, Stephen, if that makes sense. Are there any plans for a surface mount VGA part with a 9-axis output, i.e. a magnetic sensor included? Currently, no. However, David, if that's something that you're interested in, the company that ACEINNA spun out of was called MEMSIC, or is called MEMSIC, and they do have some magnetic sensor capability that we have access to. And doing a 9 degree of freedom output is something that we absolutely can do. So maybe offline we can discuss what your needs are there. Daniel, also a different Daniel, Daniel Casson has a question. What added functionality do you get with OpenIMU 300RI in the development evaluation kit using JTAG connector and the ST-Link debugger that you couldn't get with a standard OpenIMU 300RI using the RS-232 connector? Stephen or Ravi, do you want to take that one?
Yeah, I can take that one. So in terms of OpenIMU 300RI, we have two interfaces, the CAN and RS-232. So if you have like a different applications where you have like a different sensors that are connected to the CAN bus, and you want to connect the OpenIMU to the CAN bus, so in that way, we do have the CAN interface, and in the Visual Studio Code development, we do give different applications and different source code, and where you can tailor them to your CAN messages and to particular needs and applications. And you can change the CAN baud rate and the CAN output rate as well for the CAN messages that are available.
This is Jamie. Let me expand on that a little bit. The evaluation kit is really meant to help speed your development of your algorithms, and it allows you to set breakpoints in the code and to quickly build and try things. Once you've completed your development of your code, we would totally expect you to move over to just the RI unit and load the code through either the RS-232 port just by uploading the image, or and using the integrated bootloader, or coming in the not too distant future is the ability to also do that via the CAN bus.
All right, and I think Eric Smith has a question. Does the OpenIMU 330BA have a higher temperature rating than the BI version? And that Eric, we can follow up with you, but the BA version is an automotive qualified product that we're targeting for ACEINNA B, and it'll have an automotive qualification certification with it. So we can follow up with you on that specification directly. And one other thing, we will have this presentation available to all the attendees. We'll send that through to you tomorrow, so you'll have all of this documentation as well as the recording of the webinar as well. Will be available to you online, and you can access that through Zoom. We'll also send all of these slides and the presentation to our partner, WPGA Americas, so you can also request it from them directly, along with their contact information. Eric also sent another question. Do you have more detailed information on the IMU hardware? Example, self-resonant frequencies, number of pre-calibration time? Yep, including temperature point sensitivity and new sample rates, et cetera. So Eric, we do. Absolutely, we can send you some of that data. Normally, we offer that to all of our customers, and we can share with you the temperature points and sensitivity plots that we have specifically for our IMUs. But maybe offline, Eric, just shoot me a note which product you're interested in. I assume it's the IMU 330, and we can certainly send you those temperature points and the sensitivity plots. Let's see what else we have. We have another question. How about calibration of 300 RI IMU mounted on an automobile? Interested in getting orientation of vehicle.
Yeah, so we have the AHRS application also available for the OpenIMU 300 RI. So from this we get, it's also a 9 degree of freedom IMU, so it has a magnetometer on board. And there is a calibration procedure that we have that allows you to compensate for any sort of metal in the vicinity of the IMU. So there's a calibration procedure for that. And from that, with the AHRS app, you can get the orientation of the vehicle.
So I think that goes to David Kelly's question as well, is essentially what he's asking, I think, is if we have a surface mount version of a 300 RI, which is a 9 DOF with the magnetometer, but a surface mount version. So something we can think about. So thanks, Sri and David, for those questions. Something that I think Jamie and the team can review with you and take a look and see if that's something we could do for you. Any other questions at this point? Those were great questions. Let's see if we have any others. Well, I think that's it. So I'd like to say thank you to Ravi and Stephen and Jamie for putting this together. I thought it was an informative webinar. I hope you did as well. We're definitely interested in your feedback on how to make these better, more accurate, and more suitable for learning, and something that we, in this new environment, are going to have to get great at. So any feedback you have is definitely warranted and will be valued heavily. So thank you all very much for joining, and please stay safe, and we'll talk with you soon. Look for another email invitation from us for the next seminar and webinar that will be coming out in about 3 or 4 weeks' time. And we look forward to working with all of you at that point. So thank you very much to the WPGA team as well, and stay safe, everyone. Thanks so much for joining. Bye now.